Ever pondered if life exists beyond the confines of our Earth? It's a question that has piqued human curiosity for centuries. The vast expanse of the cosmos, with its countless stars and galaxies, has always left us in awe and wonder. Could we really be alone in this infinite tapestry of celestial bodies? Or are there other worlds out there just like ours, teeming with life? This fascination has driven us to look beyond our solar system, to the realm of exoplanets. These are planets that orbit stars outside our own solar system. And some of these exoplanets, incredibly, sit in what we call the habitable zone, a Goldilocks region just the right distance from their star to potentially support life as we know it. With thousands of exoplanets discovered, let's delve into 10 that could potentially sustain life. Each one a step closer to answering that age-old query, are we alone? Let's start with Proxima Centauri b, our cosmic neighbor. Nestled comfortably in the habitable zone of the Proxima Centauri star system, the closest to our own, this exoplanet piques interest for more reasons than one. Its prime location could potentially support liquid water, a key ingredient for life as we know it. Imagine an ocean world, not in some distant galaxy, but right next door in cosmic terms. The proximity of Proxima Centauri b to Earth, a mere 4 light-years away, makes it a tantalizing target for future human exploration. Its allure has captured the imagination of scientists and space enthusiasts alike, sparking dreams of interstellar travel. Could we one day set foot on its rocky surface? Proxima Centauri b is more than just an exoplanet. It's a beacon of possibility in our quest to find life beyond Earth. Could our nearest star system be our future home? Only time will tell. Next up is Kepler 442b, an Earth twin in terms of size and sunlight. Nestled comfortably in the habitable zone of its parent star, Kepler 442, this rocky exoplanet bears a striking resemblance to our own home planet. Kepler 442b is roughly 1/3 larger than Earth and receives about 2/3 of the sunlight that we do. This puts it right on the edge of the habitable zone, where conditions could potentially be just right for liquid water to exist. The star it orbits is a Type K star, a little smaller and cooler than our Sun. But don't let that fool you. It still provides enough warmth to possibly support life on Kepler 442b. It's an intriguing prospect, isn't it? An Earth-like world, warmed by a gentle star, potentially harboring the secrets of life beyond our solar system. As we continue our search for life elsewhere in the cosmos, we can only wonder what mysteries this distant world holds. Kepler 442b, a promising candidate that might one day reveal its secrets. Imagine a habitable world in a system of 7 Earth-sized planets. Welcome to TRAPPIST-1e. This fascinating exoplanet orbits an ultra-cool dwarf star, a mere 40 light-years away from us. This star, TRAPPIST-1, is so cool and small that liquid water could survive on planets quite close to it, closer than we could be to our own Sun. TRAPPIST-1e is one of these privileged worlds, nestled within the star's habitable zone. Scientists believe that it could potentially harbor liquid water on its surface, a crucial ingredient for life as we know it. But what makes TRAPPIST-1e truly captivating is the company it keeps. It's part of a unique system of 7 Earth-sized planets, a cosmic family that orbits this cool star. Imagine the view from TRAPPIST-1e's surface, with several sister planets shining brilliantly in the sky, appearing even larger than our own moon does to us. TRAPPIST-1e, a gem amidst a stellar crown, awaits further exploration. Next, we have LHS 1140b, a rocky world with a dense atmosphere. This intriguing exoplanet orbits within the habitable zone of its red dwarf star, LHS 1140. This zone, often referred to as the Goldilocks zone, is the perfect distance from a star where it's not too hot, not too cold, but just right for liquid water to exist. The exoplanet's dense atmosphere is particularly exciting for scientists. You see, a dense atmosphere could potentially provide the necessary pressure and conditions for liquid water to exist on the planet's surface. And where there's water, there could be life. What's more, the red dwarf star that LHS 1140b orbits is relatively calm. This means less stellar radiation, increasing the chances of life surviving if it were ever to develop or be transported there. So, as we gaze into the vast expanse of space, we can't help but wonder about the potential of this rocky world. LHS 1140b, a potential cradle of life in the cosmic ocean. Teegarden b, a temperate world in our cosmic backyard. Nestled within the habitable zone of its parent star, Teegarden star, this exoplanet has sparked considerable interest among astronomers and space enthusiasts alike. Teegarden b's location within the habitable zone, sometimes referred to as the Goldilocks zone, is ideal. This zone is the perfect distance from a star, where it's not too hot and not too cold, making it just right for liquid water to exist, a key ingredient for life as we know it. Now let's talk about the climate. Teegarden b boasts a temperate climate, comparable to that of Earth. This similarity in climate, coupled with its prime location, makes Teegarden b a potential target for future human exploration. Imagine a new home, a second Earth, just waiting to be discovered, studied, and perhaps one day even colonized. Teegarden b, a tantalizing target for future explorers. Ross 128b, another potential home orbiting a red dwarf. This fascinating world is located in the Goldilocks zone, where conditions could be just right for life as we know it. Not too hot, not too cold, Ross 128b boasts a similar temperature to Earth, raising our hopes of finding a second home in the cosmos. The red dwarf star it orbits, Ross 128, is smaller and cooler than our Sun, but don't let that fool you. Its proximity to Ross 128b means the planet receives only about a third less sunlight than Earth does, making it a tantalizing prospect for life to flourish. Compared to other exoplanets we've discovered, Ross 128b has a relatively calm parent star, reducing the chances of harmful flares disrupting potential life. This, along with its Earth-like climate, makes it a prime candidate in our search for a new home beyond our solar system. Ross 128b, a potential oasis in the desert of space. Wolf 1061c, a rocky world with a potentially stable climate. Nestled within the habitable zone of its parent star, the red dwarf Wolf 1061, this exoplanet boasts conditions that could make it a suitable home for humans. As we cast our gaze into the vastness of space, Wolf 1061c emerges as a beacon of hope. A rocky exoplanet, it's not too far from home, only about 14 light-years away. Its location within the habitable zone of its star means that it receives just the right amount of stellar warmth, raising the tantalizing possibility of liquid water on its surface. Moreover, Wolf 1061c's potential for a stable climate is another factor that makes it a prime candidate for human habitation. Imagine a world where the climate is stable, a world that might be able to support the complexity and diversity of life as we know it. Wolf 1061c, a potentially stable haven in the vast cosmos. Now we come to Kepler 186f, a strong candidate for life as we know it. This intriguing exoplanet is nestled within the habitable zone of its parent star, Kepler 186, a red dwarf located about 500 light-years away from us. It's the outermost of 5 planets in its system, and it's roughly the same size as Earth. The term habitable doesn't necessarily mean inhabitable, though. It simply refers to the region around a star where conditions could, in theory, allow for the presence of liquid water. And where there's water, there might be life. Kepler 186f is unique because it's the first identified Earth-sized planet that orbits in its star's habitable zone. It's like a cosmic Goldilocks, not too close to its star to boil off all water and not too distant to freeze it solid. It's this tantalizing possibility of liquid water and the Earth-like size that make Kepler 186f an exciting prospect in the search for life. Kepler 62f, a potential new Earth in the Kepler 62 system. This intriguing exoplanet is part of a 5-planet system orbiting the star Kepler 62, a star slightly cooler and smaller than our own Sun. Kepler 62f stands out due to its location in the habitable zone of its star system. That sweet spot where conditions could potentially allow for the existence of liquid water on its surface. Like an Earth twin, Kepler 62f is a rocky planet, only about 40% larger than our home planet. Its year, or complete orbit around its star, is roughly 267 Earth days. But what really sets Kepler-62f apart is its potential for life. Its location in the habitable zone and its Earth-like characteristics make it a compelling candidate for human colonization. As we gaze into the cosmos, Kepler-62f shines back at us, a beacon of hope in our quest to find a second Earth. Finally, we arrive at Gliese 581g, a disputed yet exciting candidate. Nestled within the habitable zone of its star, Gliese 581, this exoplanet sparks intrigue and controversy in equal measure. Its existence is debated among the scientific community, with some astronomers firmly asserting its reality while others cast doubt. Despite this dispute, the potential of Gliese 581g cannot be overlooked. If it does exist, Gliese 581g could potentially support liquid water, an essential ingredient for life as we know it. Its location in the habitable zone implies that conditions could be just right. Not too hot, not too cold, but just right for liquid water to pool on its surface. This tantalizing possibility has placed Gliese 581g in the spotlight, a symbol of the potential for life beyond our home planet. Whether or not Gliese 581g exists, it symbolizes our relentless quest to find life beyond Earth.